Hello, this is Jeffrey Fox again. We come to the second unit on the section on big data use cases, which covers the 51 use cases identified in the NIST Big Data Public Working Group activity from June to September of 2013. The first unit of this section described the process, and the last unit describes an overall classification that comes from trying to look at the 51 use cases from a common point of view. Here we actually go through the individual use cases, all 51, divided into categories such as government operation and deep learning and social networking and energy and physics and astronomy, etc. And we introduce also the classification, which will be done in more detail in the third unit of this group. Well, as you realize, all the lectures in this particular lecture series come with this motto of using clouds, running data analytics, processing big data, and solving problems in X informatics. And although not every use case here is actually using clouds, a lot of them are, and a lot of them are very consistent with everything we discuss in this class. So they are pretty helpful. And even the ones not using clouds, in some cases, like there are some which use supercomputers, which are not actually running applications, which are not suitable for clouds. However, those ones using supercomputers are producing data from the supercomputers, which gets integrated with, or more technically assimilated with, other data which can be stored and analyzed and probably should be stored and analyzed on clouds. Here we have our usual collage, which we update every now and then. And in this section, we go through the so-called government use cases, and there are 4 of those, and we will describe each of those 4. And these 4 will actually have quite a bit of description of the categories, because when a category first appears, we will describe it. We will not describe it when it appears later on. So you will find the earlier use cases have more discussion of categories than the later use cases. So here's our first use case, which is actually rather unusual in that it's the census data from 2010 and 2000, whereby the law of the land, the data must be preserved, and you can access it, but only perform analytics after 75 years. And the data until then is stored as is, with no access to the public and no data analytics. The data has to be preserved in the totally precise fashion, accurate to the nearest bit, and if necessary, you're going to have to change formats, because at the very least, hard disks and will probably not be hard disks. Well, it will not be what's used 75 years from now to store data, and tapes will also disappear. So quite what they will be, whether it will be a giant blancmange of biological material or some quantum pizzazz system in 75 years from now, we don't know. But the census has to do all those changes. And this is all done through Title 13 of the US Code of Law. And this current data is 380 terabytes. And here at the bottom, we have our first introduction to the categories. We will describe those on the next slide. MRStat is MapReduce for statistical analysis. SSQ is search and query. Index is indexing. And those are in blue because they're computational types. And in purple, we list the form of parallelism, because all of these things need to be parallelized. Here we have census data from every household. And so the parallelism is over households, or effectively people. So here is the slide, which will always look like this. I say they tend to be more complete in the earlier use cases, which actually use a particular idea for the first time. And we repeat at the bottom exactly the same categories we had and the same text as we have from the previous slide. And at the top here, we actually go into some detail. So it points out that we're really recording for each use case two types of information: the source of the parallelism, because as we'll discuss later in this class, parallelism is always, and we've actually already illustrated, parallelism is typically done by taking associated data, whether that data be the actual data of data or is the mesh points of simulations, chopping that data up into parts, so-called domain or data decomposition, and assigning each part of the data to a different core or a different node of your parallel machine. And here, the sources of parallelism is the people or households whose data has been gathered. And if you look at this, at actually other cases, you will find people enter in two ways. Here, because you're not allowed to look at the data, the people enter as the subjects whose data is gathered. In most other applications, they might enter both as the subjects whose data is being gathered and the viewers. Like if look to say Facebook, which actually isn't a use case, but could be, should be, or could be. Facebook, you see a lot of data from people, so you decompose that data, but also you have different people viewing it. So there you have both forms of parallelism. Parallelism in the original data and parallelism over the people using it. And the Facebook system has to support both parallelisms. And its back-end disk has the data of the people, and its front-end access must support major parallelism from all the smartphones or what have you accessing them. So the next thing, that parallelism is, as I said, always in purple. We also have in blue, the processing or computation class. And here we have three classes, which are actually typical classes of relatively straightforward, uncomplicated, traditional data sources. We have search and query, because typically you want to do what databases support very well. Do simple searches or relatively straightforward searches, often specified in SQL. And you want to well, SQL specifies the query, and you support that with indices. That's why we have the index category here, which enable those searches to run fast. Once we start using MapReduce and moving it to a more modern data processing architecture, the obvious use of MapReduce would be to take total queries and link and integrate the results of all those queries. That's the traditional actual use of map, because the reduction operation in MapReduce is one that integrates things together. In this case here, the integration is actually probably quite simple, because you're going to be looking at averages, the total worth of all population, of a population class of the people of a particular ethnic class or something like that. So these are global sums or global averages or correlations and things like that, which involve effectively a so-called reduction operation, where you take the results in each node, add them all together, and then take that final addition, which is usually done over many different things, and presenting that to the person who asked for this action. So that's called MRStat for MapReduce or simple statistics. All right, so as I said, this is just we're on use case one. We've seen the use case, and we've seen the discussion for that use case of the parallelism source and the computation and processing class introduced for the first time in this use case. We will not tend to do that again, except maybe for some things like people, which have different aspects. We sometimes repeat some of the quantities.